The next problem says a model train has a scale of 1 inch to 2 feet. If the real train is 14 feet, then how tall is the model train? Now, based on the given ratio, we say that it's a scale of 1 inch to 2 feet. So the model is in inches over the real train, which is given in feet. So I'm going to set up my proportion using this idea that I have inches over feet and inches over feet. Now the first proportion tells us that we have 1 inch to 2 feet. So I have 1 inch over 2 feet. Then it's also given that the real train is 14 feet tall. So I can fill in a 14 feet here, and this means that this number of inches is what I don't know. So now if I rewrite this as a proportion, so I can focus just on the solving, I have 1 over 2 equals x over 14. So if I cross multiply, I get 2 times x, which gives me 2x is equal to 1 times 14, which is equal to 14. And then when I finish solving, I get x is equal to 7. Now I can see from above that the units of the unknown is inches, so my answer is 7 inches. This example says Abbott's rides in Santa Cruz are 9 centimeters apart in a map that has a scale of 1 centimeter to 13 kilometers. How far apart are the real cities? So I'm going to start by identifying my scale. Now the scale that's given to us is 1 centimeter to 13 kilometers. So I'm going to set up my proportions as being centimeters over kilometers. So we know on both sides, all centimeters over kilometers and centimeters over kilometers. Now the scale that's given to us is 1 centimeter to 13 kilometers. So I have 1 centimeter to 13 kilometers. It also tells us that we have Santa Cruz and Abbott's Rise, which are 9 centimeters apart. So I have a 9 that goes on the top, which means that this x, kilometers, is what I don't know. So if I rewrite this as 1 over 13 equals 9 over x, to ignore my units, so I can focus on solving, I get 1 times x, which is x, and 9 times 13, which gives you a value of 117. And we see from what's unknown above, our units was kilometer, so our answers is 117 kilometers. The next example says, if a 5-foot tall woman casts a 4-foot long shadow, then how tall is a statue that casts a 12-foot shadow? So if I start by drawing a picture, I know that the 5-foot tall woman casts a 4-foot shadow. So here is my woman with her height of 5 feet, and her shadow is 4 feet. Then the problem says that the statue, we don't know the height, but it casts a 12-foot shadow. So if I have my statue is here, I don't know what the height is, so I'm going to label it as x, but we know that the shadow is 12 feet. So if I set up my proportion, the height of 5 feet goes with the height of x. So I could say that 5 over x is equal to the shadow of 4 feet and the shadow of 12 feet. So it's 4 over 12. Now if I cross multiply, I'll have 5 times 12, which is 60, is equal to 4 times x, which is 4x, and then you solve to get that x is 15. So your answer is 15 feet. In the next example, it says that a 6-foot tall baby giraffe casts a 3 feet long shadow. So if this is my baby giraffe, we know that the baby giraffe is 6 feet tall and its shadow is 3 feet. We also then know that the adult giraffe casts a 7-foot shadow. So I have the adult giraffe, which has a height of we don't know, but we know that the shadow is 7 feet. So I can use this to set up a proportion because my height of the baby giraffe of 6 goes with my unknown height of x. So I can say 6 over x is equal to my shadow of the baby giraffe, which is 3, over the shadow of the adult giraffe, which is 7. Now if we want to solve, we would cross multiply. So we have the 6 times 7, which gives us an answer of 42, is equal to 3 times x, which is 3x, and you divide 42 by 3, you get an answer of 14 is equal to x. So our answer is 14 feet. The next example says a ramp slopes upward from the sidewalk to the entrance of a building in a constant incline. If the ramp is 2 feet high when it's 5 feet from the sidewalk, how high is the ramp when it is 7 feet from the sidewalk? Now I'm going to start by drawing a picture. So I have that this is my ramp, where we know that this is the sidewalk, and this is the entrance to the building. Now what it says is if the ramp is 2 feet high when it's 5 feet from the sidewalk, so when this length is 5 feet, you know that the height is 2 feet. It then says how high is the ramp when it's 7 feet from the sidewalk. So if we know that we're talking about this portion of the sidewalk, which is 7 feet, how high is the sidewalk there? So what I can do is set up my proportion. So I know that the distance from the sidewalk is 5, goes with the distance from the sidewalk of 7 feet. So you could say 5 over 7 is equal to the height of the first part, which is 2, over the unknown height at the other distance, which is x. So if I want to solve, I would cross multiply. So I do 5 times x, which gives you 5x, and 7 times 2, which is 14. And then when I divide both sides to solve, I get 14 divided by 5, which gives us an answer of 2.8 feet. Next example says Private Eye Samantha Diamond places a mirror on the ground between herself and an apartment building and stands so when she looks in the mirror, she sees in the window. So if I start by just drawing a picture, I have here is Samantha Diamond, and here is the mirror she's looking in. What's happening is this is my building, and she's using this to look in some window up there. So her line of sight allows her to look from her eyes down to the mirror, and in the mirror she can look back up and see in the window. Now I can use this to draw a full triangle because this becomes her height and the distance on the ground, and this becomes the building height and the distance on the ground. So now if I label, it says the mirror's crosshairs are 1.22 meters from her feet. So I know that the mirror crosshairs are right here. Since the distance from her feet is 1.22 meters, then it tells us that the mirror crosshairs are 7.32 meters from the base of the building. So we know that this is 7.32 meters. We also know that her eye is 1.82 meters above the ground. So that means that this height is 1.82 meters. And the unknown is this height over here. So what I don't know is this height of the window, which is x. So if I want to set up a proportion, I can set up so I match my corresponding sides. So I have the 1.22 meters on the ground corresponds to the distance on the ground of 7.32. So I have 1.22 over 7.32 is equal to, and I can match that, the height of 1.82 corresponds to the building height of x. So 1.82 over x. Now to solve, I would cross multiply. So I get 1.22x is equal to 7.32 times 1.82, which gives you a value of 13.3224. Then you divide both sides by 1.22, which gives you an answer of 10.92 meters. In the next example, I'm going to draw a picture. So I have that Melody casts a shadow that is 84 inches. So I have the sun is shining, and Melody is standing here, and her shadow is 84 inches. Her height, we also know, is 5 feet. Melody's friend is also standing. So here is her friend. And we know is that her shadow, or his shadow, is 1 foot shorter than hers. So if her shadow is 84 inches, then we know that 1 foot is equal to 12 inches. This means that his shadow is really 1 foot, or 12 inches, shorter. So this length for him is 84 minus 12, which gives you a value of 72 inches. What we don't know is this height, which I'm going to call x. So now if I set up my proportion, the height of 5 feet goes with the friend's height of x. So I have 5 feet over x is equal to her shadow of 84 inches over the friend's shadow of 72 inches. Now when I cross multiply to solve, we have 5 times 72, which gives you a value of 360 is equal to x times 84. So it's 84x. And when you divide both sides by 84, you get an answer of 4.29 feet as the friend's height. I can also multiply that number of feet by 12, so it would also be 51.43 inches. The last problem says Juanita, who is 1.82 meters tall, wants to find the height of a tree in her backyard. From the tree's base, she walks exactly 12.20 meters along the tree shadow to a position where her shadow exactly overlaps the end of the tree shadow. So if I draw a picture, I can start by drawing my tree. So I have here is my tree. And here is Juanita. Now we know from the given information that she's 1.82 meters tall. So we know this length is 1.82 meters. Now it tells us that she walked from the tree's base 12.2 meters to a shadow, so they're a position where a shadow overlapped the end of the tree shadow. So this means from where she is, if this is the tree shadow, her shadow ends up in the exact same location. And we know that this distance that she walked is 12.2 meters. We also know that she is now 6.1 meters from the end of the shadow. So this distance is 6.10 meters. How tall is the tree? So the unknown information that we're looking for is this height of the tree, which I'm going to call x. Now, if I want to match things up, we know first that the height of Juanita of 1.82 meters corresponds with the height of the tree, which is x. So I can say that 1.82 over x. Now the other part of the proportion we need to deal with is the length of the shadow. Now the length of Juanita's shadow is just this part, which is 6.1. I have 6.10 over the length of the tree's full shadow, which is combining those two, and that's a length of 18.3 meters. So this is 18.3. Now to solve, we're going to cross multiply like we normally would. So I would have 1.82 times the 18.3, which gives you a value of 33.306, and x times 6.1, which gives you a value of 6.1x, and then you would divide both sides by 6.1 to get your answer as 5.46 equals x, and we know that this is given in meters.